Hi everyone, this video is on exercise 12b from pure 1 question 2. So we have the function f of x is x squared, and in part A we want to show that f dash x is equal to the limit of 2x plus h as h tends to 0. So part A is essentially saying that show that the derivative of f of x is equal to this limit by using the first principles. So we first need to write down the formula, and that's always we always start questions like this when it's about differentiation from first principles is f dash x is equal to the limit of f of x plus h minus f of x divided by h as h tends to 0. Okay, now in the next step we want to substitute the function because our function is x squared and we want to substitute f of x plus h. So x plus h squared is going to be the first term on the numerator, and then the next term is just minus f of x, which means minus x squared because that's equal to f of x. And then we have h in the denominator. So the next step is just expanding and simplifying. So we need to just keep writing this limit, and then here as h tends to 0. So we are going to have x squared plus h squared plus 2xh minus x squared, and this x squared cancels out with minus x squared, and we can also divide each term by h, because if we do so then we won't have any h on the denominator anymore, and then here this h will be gone, and then same with this h on the power. So all remains is equal to so we don't have a fraction anymore. It's going to be h plus 2x. And that's exactly what we wanted to show. So we wanted to show that the derivative is equal to this limit. Okay, now in part B, we simply want to find the limit, right? So because it says that show that f dash x is equal to 2x, that just means that find the limit. Okay, so for this part, we just need to understand what does the limit mean here. So we have a function. So let's say we have this, and then we want to know what's the limiting behavior of h plus 2x. So that means what happens to this function as h gets extremely close to 0, but not exactly 0. And if h gets very, 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 very small, then obviously it will almost have no effect. If it gets very close to 0, then only 2x is going to be the main term. So that's basically the answer. So yeah, in questions like this, it's almost like substituting 0 into h. Yeah, so substituting, the reason I'm not saying always think of these limits as just substitution, because this doesn't work all the time. In fact, in most of the cases, this doesn't work. But as long as you get some nice polynomials in in A-level maths, then yeah, substitution should be fine. But yeah, there are many cases that substitution fails and you need to use other methods. So that's why I'm not saying don't try to substitute this all the time, but rather try to understand the meaning of the limit and try to just think what happens as h gets close to a certain value. Okay, so that's it for this video. And yeah, I mean, for the solution of b, we can write, yeah, I forgot to write it before I end the video. Let's just write that because I forgot to write the solution I just explained. So you can say as h tends to 0, then 2x plus h tends to 2x. So f dash x is equal to 2x. Now the thing is that writing this just it depends on the question. Like, yeah, it's better that you get into the habit of writing this final line, because this is more like a conclusion at the end. However, if you don't write this, it just depends on the question, because in some questions you won't be penalized. But in this question, obviously, since it says hence deduce that f dash x is equal to 2x, if you just copy and paste just f dash x is equal to 2x, even if you know what's going on in your head, then that won't be enough to get some marks in your exam. Yeah. Okay, that's it for this video, and thank you for watching.